Okay, so picking up in lesson 1.6, we graphed. We're working on substitution. What was the idea with substitution? Okay. What was the question I had to ask myself to get started here?
Is there a variable that's by itself?
Okay, yeah. Do I have an equation that is either x equals or y equals, right? On the first example, we had y equals. Second example, we had x equals. This third example, I didn't have x equals or y equals, so what do we have to do? We had to make it happen, didn't we? So like we used this x plus 2y, so we subtracted the 2y over to get it so it's x equals. Okay, so that was the gist of what we were doing. And once we would get it, we would then sub it into the other equation. Okay, have you tried the last example yet? So, do we have an equation that's x equals or y equals? Okay, we have 2y equals. And what do we really need it to be? We need it to be 1y equals or y equals, right? So that would be the one I'd use. I would say no, we don't have an x equals or y equals equation, but this one that is 2y, how can we make it to be y equals? Divide by 2. So if I divide each piece by 2 here, we end up with the equation y equals what? 3x minus 1. 6x divided by 2 is 3x, minus 2 divided by 2 is minus 1. Once you have an x equals or y equals equation, what do? We gotta substitute into the other equation, right? So here, every place I see a y, we're going to replace it with that 3x minus 1. So negative 6x plus 2 times y. What's y? 3x minus 1. And that equals 8. Okay, do the math. Negative 6x carries down. We're going to take the 2 and we're going to distribute. 2 times 3x is 6x. 2 times negative 1 minus 2 equals 8. After we distribute, next step is to can we clean up some like terms here? Some of you are kind of hesitating on me all of a sudden. What is negative 6x plus 6x? It's 0, yes? You could say 0. You can say 0x. Now, someone this morning, I had several people this morning try and tell me x. Is it x? No, because if you're going to tell me x, I'm hearing 1x if you say x. So it needs to be some kind of 0. Or you can just not even put anything. They just cancel. And then I still have minus 2 equals 8. What is 0 minus 2? Negative 2 equals 8. Now what? What's the situation we have here? I don't have an x or a y, do I? We had an x, but it just canceled out. So, when you have your variables cancel out, whether it be x's or y's, so when you get to an equation that has no variables, you have two options. Your answer is either no solution or infinitely many solutions. My variables canceled out, so it's no solution or infinitely many solutions. Which is it?
No solution.
And why no solution?
Because I feel like if it was infinite infinitely many, then you would have
Okay, yeah.
something along this line. But
Here's
you
the,
have variables
yeah.
still.
Does negative 2 equal 8? No, here's that key. That is a false statement. That is a very false statement, right? Negative 2 equals 8. And so since negative 2 does not equal 8, this is no solution. Now, had you done this problem a little differently, maybe you would have come up with 0 equals 8, or negative 2 equals 10, or regardless, any of those non-true solutions are going to be no solution. If your variables cancel out, but you get a true statement, so say you've got an 8 equals 8, then that's when we would say infinitely many, if you get a true statement. But a false statement such as this, no solution. So that's one of those specialties you'll come up with at times. Okay. Hopefully you have a little bit of a grasp on substitution. Let's try elimination then. Okay. Substitution works great when there's an equation that is x equals or y, or an equation where you can easily get x equals or y equals. As you look at our first elimination example, I don't know about you, but I don't really want to substitute here. I mean, it's not in the substitution section, so we're not going to, but I don't really want to solve either of these for x or y because it's not going to be pretty. I'd have fractions involved, and that's no fun. So we're going to eliminate instead. We're going to eliminate a variable by adding our two equations together. Now, in this first example, which equation is set up, which variable is set up to eliminate? Are we set up to eliminate x's or y's? And why x's? Yeah. First of all, they have the same coefficient. They're both 4x's, yes? And even better is that we have a positive 4x and a negative 4x. So, because they are the same number in front of them, opposite signs, we can take these two equations and we can add them together. I'm not going to rewrite the problem. I'm just going to draw my line and I'm going to start adding. They're already lined up like pieces, but you always add like pieces with like pieces. 4x plus negative 4x. 0, yes? And that's what we wanted. We wanted it to cancel out. You can put it 0x. I usually write nothing. 2y plus 3y. 5y. Carry down your equal sign. 9 plus 16. 25. I don't know about you guys, but that looks pretty easy. I now have the equation 5y equals 25. What do we do to solve? Okay. Divide by 5. If 5y equals 25, we divide by 5. We're going to get y equals 5. Am I done? I see lots of head shaking. Why am I not done? I don't have an X, right? I need an ordered pair. I have half my ordered pair. I need the whole ordered pair. So if I stop right now, what I know is that my answer is something comma 5. How do I find that something? Sub it in where? Okay. Pick one of your original equations. Take that y equals 5 and put it in. Doesn't matter which one you use. No. You get to pick which one looks more interesting to you. I would say more fun. I'm not sure fun is a great word to put in there, though. But, you know, which one looks better to you? I think I heard the top. Smaller number, no negative, so there's the advantage to the top, yes. It doesn't matter. So I'm going to take this top equation. I'm going to take my y equals 5. We're going to combine it. 4x plus 2 times 5 equals 9. Do the math. 2 times 5 is 10. So 4x plus 10 equals 9. If it's 4x plus 10, subtract 10. 4x equals 9 minus 10 is -1. This is where you say, it's not going to divide, but, we just have to write down the answer. It's all fine. If it's 4 times x, we're going to divide by 4. What is -1 divided by 4? Yeah. I would leave my answer as -1/4 here. So when I give my answer, I'm going to say -1/4, comma 5. Savas uses that Math Excel piece inside of it, and it's 50-50. Will they accept a decimal, or do you have to put a fraction? Depends on the day, right? You guys are familiar with Math Excel. It's a little rough at times knowing how to put the answer, but just watch for it. Me personally, if you're doing this for paper on me, -1/4, -0.25, I'm fine either way. Math Excel is the one you have to please though for homework, right? Savas, Math Excel, whatever. Okay, elimination sound a little familiar? No? Maybe? Okay, I'm seeing a few nods. Well, what changes on this next problem? Yeah. What am I set up to eliminate? I'm set up to eliminate y's because they're both 8y's, right? However, last time I was set up with a positive and negative so that when I add them, they cancel to be 0. This time, well, I can't add them as is, because if I add them as is, 8y and 8y is not 0, 1. Now, I can teach this 2 different ways. I used to teach, if it's positive 8y and positive 8y, we could subtract them. And so I could just subtract my 2 equations. And I'm okay with that. However, the problem I found out over the years is that we tend to run into a few more careless sign mistakes. But if you want to subtract, I'm perfectly okay with that. The other option, though, instead of subtracting, is let's take one of our equations and multiply it by a -1. Okay, so if you multiply by a negative, that's going to change all your signs. It doesn't matter which. I personally am going to multiply the bottom by -1. And I'm going to rewrite my equations. The top equation I'm going to keep as is. -2x plus 8y equals -8. The bottom equation, when we multiply by a negative, basically we're changing all the signs. So -5x becomes positive 5x. Plus 8y becomes minus 8y. -20 becomes positive 20. And now my signs are opposite. So I'm ready to add my 2 equations. What is -2x plus 5x? 3x. 8y plus -8y. That's 0. You can write it down, or I just leave it out. Carry down my equal sign. -8 plus 12. You knew what I was looking for. I actually just said -8 plus 12, though, didn't I? Okay, let's try this again. -8 plus 20 is 12. See, my brain was working ahead. If I have 3x equals 12, what are we going to do? Divide by the 3. And we get an answer of x equals 4. Am I done? Nope, only if you want half credit. It'd be a shame to come this far and only get half credit. What do I do with that 4? Plug it into one of them? Which one? Top one? It doesn't matter. It doesn't matter. So if we use the top one, negative 2x, which is 4, plus 8y equals negative 8. Negative 2 times 4 is negative 8 plus 8y equals negative 8. That's a lot of 8's. How do I get the y term by itself? This is negative 8. We're going to add 8. Negative 8 plus 8 is 0. Leaves me with 8y. Negative 8 plus 8? 0. Should I stop here? Am I done? No. 0 is a number, guys. Keep working. Okay, common mistake I see here is, oh, there's a 0, no solution. I'm done. I quit. No, 0 is a number. Keep working. How do I solve for y? If it's 8 times y, we're going to divide by 8, and y is 0. 0 divided by anything is 0. So final answer of 4, 0. And all of these, as I go through, guys, remember, there's not just one exact way to do these. There's lots of different little side paths you can take along the way. Okay. Well, if that's coming back to you, I'm going to go to another screen. What about this next one? 2x plus 7y equals 4, and 3x plus 5y equals negative 5. What's different about it? We don't have anything matching up this time, do we? My x's don't have the same number. My y's don't have the same number. So what's the new plan? What do you remember?
Do you multiply the first equation by something and the second equation by a 2x so that the two numbers will match?
Yep. Yeah, so we have to pick here. We can either pick and make the x's match, and we can multiply the top and the bottom equation by something, or we can pick and make the y's match. Technically, we can do either or. If we try and make the x's match, what are we trying to make those x's become? 6x, which officially, if you want me to throw the vocabulary out there, you probably don't, but we're looking for the least common multiple between 2 and 3. In other words, if 2 and 3 were my denominators, what would be the least common denominator between 2 and 3? 6. Now, so we can do 6x, or if we wanted to do y's, what could we do for y's? 35y. So we can either make both 6x's or both 35y's. I'm guessing you guys would prefer to go the 6x route. Okay, technically it doesn't matter, but, and so if that's the case, we're going to multiply this top equation by what? 3. The bottom equation by 2. Now, let's tweak one of those just a teeny bit. Can we throw a negative in there somewhere? And the advantage of throwing a negative in there is I'll end up with a positive 6 and a negative 6. And again, I'm going to say officially it doesn't matter which one you make negative. Okay, I'm going to make my bottom one negative. And here we go. Top equation, when I multiply by 3, 6x plus 21y equals 12. Bottom equation, I'm going to multiply by negative 2, so all my signs are going to change along the way. Negative 6x minus 10y equals positive 10. My x's have the same number in front of them, opposite signs, right? So, with that in mind, I am ready to add. 6x plus negative 6x. Big old 0x, it's gone. 21y plus negative 10y. 11y. Carry your equal sign down. 12 plus 10. 22. If it's 11 times y, divide by 11, and y is 2. Am I done? I love it. I'm getting the head nods at least. You guys know I'm not done when I just have one answer, right? We keep going. Which equation do you want? Let's say the only slight advantage in the top one is there's no negative. That's about the only slight advantage. They're very similar otherwise, aren't they? So, if I use the top one, now, I guess I need a comment about this. I'm going back to the originals. Okay? To me, the originals have smaller numbers. I'm going to use the originals. Could you use the ones you multiplied by over here? You could. But for me, I'm going to go back to the originals. So if I use the top, 2x plus 7y, which is 2, equals 4. 2x plus 14 equals 4. If it's 2x plus 14, I'm going to subtract 14. (2x) equals, what's 4 minus 14? Negative 10. Divide by 2, and x is negative 5. So we have a final answer of negative 5, comma 2. Okay. That's kind of the full extent of elimination. All those pieces coming back. You did this 2 years ago in Algebra 1, right? How much you remember of it, I don't know, but I know you did it. Okay, 2 more. Bottom one's kind of a special case. We'll get to that one here in a moment. Let's look at this one. 3x plus 7y equals 15. 5x plus 2y equals negative 4. You want to eliminate x's or y's? Okay, I already heard x's, I heard y's. If we eliminate x's, what are we going to make them? 15, right? If we eliminate y's, what are we going to make them? 14. They're pretty close, aren't they? I personally am going to eliminate y's this time just because I eliminated x's last time. Does that mean you have to go the same direction I go? No, not if you feel comfortable with what you're doing, you could go the other direction and should be able to meet me in the end. We're still going to get the same answer, right? So if I'm going to eliminate y's, what am I multiplying by? My top is 7, so I'm multiplying by 2. My bottom is 2, so I'm going to multiply by 7. I'm going to make it a negative 7. They don't already have opposite signs, so I'm going to multiply one of them by a negative. Okay, here I go. Multiplying my top by 2. 6x plus 14y equals 30. Multiplying my bottom by negative 7. negative 35x minus 14y equals 28. My 14y's have opposite signs, so I'm going to add. What is 6 plus negative 35x? Negative 29x. Looks a little scary because that's not a normal number, but give it a chance. 14y plus negative 14y, 0. Carry my equals down. 30 plus 28, 58. Does it work?
Yes.
Yeah. Divide by negative 29, and we have an answer. What is 58 divided by negative 29? Negative 2. Not done? We're going to finish up the last piece. We're almost there. To be different, I'm going to use the bottom one this time. You don't like it, use the top. We'll get the same answer, assuming we don't make mistakes. 3x. So 3 times negative 2. I just said I was going to use the bottom, didn't I?
Yeah.
I'm going to use the bottom, dang it. I'm going back and using the bottom. Okay. And I'm going back to the original. Let's try this again. 5x. Goodness. So 5 times negative 2 plus 2y equals negative 4. 5 times negative 2 is negative 10 plus 2y equals negative 4. To get 2y by itself, we're going to add 10. So 2y equals negative 4 plus 10, which is 6. If 2y equals 6, divide by 2, and y is 3. Final answer. Math Excel, Savas, whatever. They're not going to let you just leave it like this, are they? No. Ordered pair, negative 2, comma 3. Okay. One last example. If you haven't already observed it, you'll notice it's kind of weird, right? Kind of special. Do you want to eliminate x's or y's? Okay. Answer whichever you want, because it's already set up for both, isn't it? We've got a positive and a negative 3x. We've got a positive y and negative y. You can answer whichever you want. We're set up for it. So let's add. What is negative 3x plus 3x?
0.
0. Okay. What is y plus negative y? 0. So what remains on that left side? 0. All of my variables are gone. That means something. What's negative 5 plus 5?
0.
0. Okay. Reference what I said earlier. When the variables cancel out, which is what happened here, I have 2 possible answers, right? No solution or infinitely many solutions? This one?
Infinite.
Infinitely many solutions because the 0 equals 0. Yes, it does equal. So because we got a true statement, we're going to say infinitely many solutions. It's kind of the same idea of saying all real numbers. We just don't traditionally say all real numbers in this situation because it's ordered pairs. So they're each a solution. So infinitely many solutions. Now, if you did something different, maybe you ended up with 10 equals 10. Who knows? You know, as long as you get a true statement here at the end, it's going to be infinitely many solutions. Okay? Okay. Your homework that is available now and is due tomorrow is lesson 1.6, and I called it lesson 1.6 part 1. And it is, of course, in Savas. And did I get you a little bit of work time? Ooh, I did good on that. Maybe like 12 minutes.